Welcome to Lyons Township High School Physics C. Today we got an example involving capacitance, and specifically two capacitors that are already charged up, connected to each other, and then we're going to insert a dielectric into one of the two capacitors and see what happens. So situation looks like this. You got two capacitors. We'll call that one C1, and it's C1 naught. Another one over here. That's C2 naught, okay? They are attached like so, okay? And they are charged up. So this one has a Q1 naught and this one has a Q2 naught. They are charged up at some voltage V naught, and they are connected, so they would have the same voltage. And what we're going to do is we're going to take a dielectric, and we're going to insert that such that it fills the entire space of this capacitor. And what I want to find out is what is the final voltage compared to the initial voltage of our system. And I want the final voltage in terms of the original capacitances, the dielectric constant, and V naught. Okay? So, and then we're going to talk about like what happens to charge and what happens to energy and so on. So the first thing you're going to notice is that beforehand, this charge plus this charge, and we'll assume the top of the plates are positive and the bottom of the plates are negative. This charge plus that charge equals the total. Okay, so we're going to say that Q total is Q1 naught plus Q2 naught. Okay, and when I insert the dielectric, these charges may move around, but the total isn't going to change. So for instance, let's say some of these guys migrate over to here. The total charge on this plate and this plate added together is still going to be the same. So this is going to be Q1 plus Q2, and those are the final values of Q. So the total before and the total after are going to be the same. Now, I do know that Q equals CV in general. Charge is capacitance times voltage. So if I basically Q, I'm going to take CV for each of these. So here we got C naught V naught plus, or C1 naught V naught plus C2 naught V naught. Afterward, I've got a C1 V final plus I've got a C2 naught V final. Now, C2 didn't change, okay, but C1 does. When you insert the dielectric in there, basically all that happens is this value goes up by that number. So I'm going to put that in here. I'm going to put kappa times C1 naught. So you got C1 naught V naught plus C2 naught V naught equals kappa C1 naught V final plus C2 naught V final. And basically we're going to solve for V final now in terms of V naught. So we just do a little bit of algebra. I factor out the V naught here. So I get V naught times C1 naught plus C2 naught equals, over here I factor out the V, and you got kappa C1 naught plus C2 naught. And you get V by itself, and I'll write that over here actually. So you get V equals C1 naught plus C2 naught times the original voltage over quantity kappa C1 naught plus C2 naught. Okay, so that's your new voltage. A couple quick notes on the new voltage. Because this is bigger than 1, then V final is less than V naught. Okay, meaning the system actually did work to pull the dielectric in. In other words, the system would suck that dielectric in. I wouldn't have to shove it in. Also, since voltage went down, this charge goes down. This charge actually goes up. In other words, some charge swings from C2 over to C1 because now C1 with the dielectric in there, C1 is it more easily stores charge. It has an easier time storing charge, so it will store more of the total charge that's there. So real simple problem, and there you go. Hope that was helpful. Thank you.